Hello everyone, I am Somu from Devghar, India. I am a mathematics teacher at Abhishek Coaching. Today I'll discuss the topic Trigonometric Identities for grade 10 for cbse board. So let's student discuss about the reciprocal identities. Okay, so I guess you have heard about these identities. I guess cosec theta equal to 1 by sin theta. Is it? Sec theta equal to 1 by cos theta and cot theta equal to 1 by tan theta. I guess you know about all these things, but then also we have to remember them. So it will be very easier for us to do the questions. Okay, so if I have cosec theta equal to 1 by sin theta, so I can very easily write sin theta will be equal to 1 by cosec theta. Very easy. Then if I have sec theta equal to 1 by cos theta, so I can very easily write cos theta equal to 1 by sec theta. Very easy na. One more thing, cot theta is 1 by tan theta, so tan theta will be equal to 1 by cot theta. Very easy. So I can remember all those. Is it, children? Very easy. So let's remember two more identities. Okay, so if I have tan theta, okay, although I have tan theta is equal to 1 by cot theta, I have one more identity, tan theta equal to sin theta by cos theta. Very easy na. Tan is sin by cos. Now I can very easily write cot theta also in terms of sin and cos. So how can I write? Because tan is reciprocal of cot or cot is reciprocal of tan, so hence we can write cot theta as cos theta by sin theta. Very easy. So let's do some question regarding this type of sums. Okay, so let's do this sum. So tan theta is tan theta by 1 minus tan theta minus cot theta by 1 minus cot theta equal to cos theta plus sin theta by cos theta minus sin theta. So moving ahead, so we take the LHS, left hand side. So in the left hand side I have tan theta by 1 minus tan theta. In place of tan theta I can write what? Sin theta by cos theta. Just now we have studied. Now 1 minus tan theta I can write 1 minus sin theta by cos theta minus cot theta I can write cos theta by sin theta and cot theta I can write cos by sin. Very easy till now. Now let's move ahead and do the LCM over here. So sin theta by cos theta by, we can write cos minus sin, cos theta minus sin theta by cos theta, and cos theta by sin theta by, we can write over here sin theta minus cos theta. Very easy. Now we can cancel cos and cos, we can cancel sin and sin, no issues. So I'm left with sin theta by cos theta minus sin theta minus cos theta by, see, sin theta minus cos theta I have. Okay, so I can interchange cos and sin, then I can put a minus over here. Okay, if I interchange sin and cos, I have to take minus common from both of them. So as I take common, what I can do here, sin by cos minus sin, minus minus become plus, cos by cos theta minus sin theta. Now it's again very easy. Do you know the LCMs are same? I can write cos cos theta minus sin theta. On the bottom and on the top I can write what? Sin theta plus cos theta. Do you know I can do one more thing? I can interchange on the numerator part because it is a plus cos theta plus sin theta by cos theta minus sin theta. Very easy, done. So as you can see, the LHS part I have approached and solved to get the right hand side. Easy enough. So let's move on to do another question of this type only. Before that, let's understand one more identity. Okay, let's understand one more identities about the Pythagorean identities. That is, so let's study about these Pythagorean identities. Okay, so we have the first Pythagorean identity, that is sine square theta plus cos square theta, okay, equal to 1. Easy. Then sec square theta equal to 1 plus tan square theta, and cosec square theta equal to 1 plus cot square theta. So let's break these formulas and make new formulas. So if I want to get sine square theta, so then what I need to write? 1 minus cos square theta. Very easy. Or if I want to get cos square theta, then I can very easily write 1 minus sine square theta. Now let's go and break this formula into steps. Suppose if I need to write tan square theta, then sec square theta minus 1. Very easy. And if I have tan square theta minus sec square theta, then what I'll get? Minus 1. If sec square theta minus tan square theta, then very nice, 1. So let's break this formula also and see. If I want to write cot square theta, then cosec square theta minus 1. Very easy. Or if I want to write cot square theta minus cosec square theta, then minus 1. Last, if I want to write cosec square theta minus cot square theta, then 1. No issues, I guess, children? No issues? Can remember each one of them very easily, but the main important one are these three. Sine square theta plus cos square theta equal to 1, sec square theta equal to 1 plus tan square theta, and cosec square theta equal to 1 plus cot square theta. Let's go ahead and have some questions to solve, okay, with these relations, okay. So let's solve this. We have to prove this. Sin a plus cosec a whole square plus cos a plus sec a whole square is equal to 7 plus tan square a plus cot square a. So let's take the LHS, and you know, a plus b whole square, a square plus b square plus 2ab. Is it? Then let's break cos a plus sec a whole square. So we have cos square a plus sec square a plus 2 cos a into sec a. Now you know sin square a plus cos square a. Sin square a plus cos square a. We get 1, is it? Then again, let's see. Sin a into cosec a, we get 1. As you see, sin and cosec are reciprocal of each other, so if they are multiplied, so we get a 1. Let's take up cosec square a. Cosec square a, we can very easily write 1 plus cot square a. Sec square a, if I talk about, I can very easily write 1 plus tan square a. And you know, cos a into sec a is what? 1, because they're reciprocal of each other, so 2 into 1. So here sin square a plus cos square a, I get a 1. Here I get a 2. Here I get a 1. Here I get a cot square a. Again a 1. Again tan square a. And again 2. So let's add up 2 and 1, 3 and 1, 4 and 1, 2, 6 and 1, 7 plus tan square a plus cot square a. Done. You can see the right hand side is verified. Okay, fine.